Your guide is Vinnie de Padova. Jewelry repair pricing is usually based upon an hourly rate. It varies and depends on overhead, clientele, and profit requirements. Time is the most vital asset to be considered when pricing. The repairman must systemize work so that similar jobs can be in sequence. Vinnie de Padova is a professional repairman and brings his knowledge to this tape. Lee Martin asks questions to expand on the teaching technique. Basic jobs in jewelry repair is sizing a ring, reducing the size or enlarging it. This is a view of a ring prior to work being done on. And this one will be reduced in size. Right now it's between an 8 and a 9. And before you start, I'd like to have a few questions I want to ask you. When a customer walks in, how do you know exactly what size to make the ring? What determines it?
Okay, when a customer comes in to have their ring size, first thing we'll do is take these ring sizers and determine what size their finger is. The ring sizers should slide over the knuckle kind of hard, and then once it's on the finger, be comfortable, and that'll determine their size.
Why do people have to have ring size? Well, you'd think when they buy the ring, it would be a perfect fit.
Most rings are made a standard size. Usually a woman's ring is about 6.5, or sometimes the people will buy a used ring that was fit somebody else's finger, or they could have lost weight and their finger got smaller, so their ring needed to be brought down to that size also. So there's a number of different reasons.
Do you always cut the ring in the bottom of the shank, or are there any reasons why you might want to cut elsewhere?
Sometimes there'll be engraving in the ring, and you'll try to avoid that if you can. You might want to cut the ring so as to avoid the engraving. Or the ring might be very thin at the very bottom, and you'll want to size it off to the side where the ring's a little bit thicker, because it will become a little bit thinner from the polishing and the sanding and filing. We're going to start now with sizing down this ring. This is a ruby and diamond ring, and we've determined that the size of the ring now is an 8 3/4. This customer wants to have a size 7 now. So what we're going to do is cut out enough metal to make it go down from an 8 3/4 to a size 7. Now, that's 1 3/4 sizes. Each size is approximately 2.5 millimeters. So what we're going to do here is figure we're going to cut out about 4 millimeters, and that should be real close. So this ring is a little bit thin at the very bottom, so what I'm going to do is cut the area right over here and remove some. Take one cut through, and then what we can do is take a millimeter gauge and measure 4 millimeters, eyeball that, just make a little mark so you can tell where 4 millimeters is for your next saw cut. We're going to replace a blade here in the saw, and usually use a 4/0 blade. And to insert the blade into the saw, you point the teeth towards the handle, slide it in the bottom of the saw blade and tighten it up. Put some pressure on the frame, saw frame, and then tighten the top down. A nice steady flowing motion.
The ring has now been cut. Approximately 4 millimeter of the band has been removed, and it will be completed by the following steps.
With round nose pliers now, we're going to close up the band and bring it down to the right size and check it on the mandrel. So what we're doing is bringing the shank together, the section that we cut out. Just adjust it until it fits nice and snugly together. There's no gap.
I noticed the way you adjust it is to move each part of the band past each other, and then let the spring sort of make the contact by pulling back.
Sure. That's the way we do it. Okay, now with it together, we're going to double check the size on the mandrel. And we see that that's real close to a 7. And then what we'll get ready now to do is the soldering.
What type of solder do you use? What hardness?
Okay, for repair of shanks, we always use a hard solder. It will closely match the gold in the shank, and so we won't see a solder seam.
If there are previous repairs on it and you use hard solder, is there a danger of it dissolving the other solder?
If the ring's been sized before and it wasn't done with hard solder, and there's a solder joint, you can usually see the solder joint, and you want to avoid that. You want to avoid that area, or else remove that area.
Can you use a heat protector solution on that, a yellow ochre or something like that, that might prevent heat from reaching it? I'm speaking of this pre-soldered joint.
Sure. You can either avoid it by pointing your torch away from it, or using some kind of a heat shield. Yeah. Okay, now what we're going to do is we've placed the ring in the third hand, right here. And we're going to fire coat the ring to protect it from discoloration and to protect the stones. So the fire coat is a mixture of boric acid and denatured alcohol. So we've coated the ring with that, and we'll take our torch. This torch that I use is I use natural gas and oxygen. There are different combinations, but I prefer this. So what we're going to do is burn the fire coat off the ring now and preheat it. And then we're going to take, I have a little brush that I use to apply flux. So we're going to put a little bit of flux on the joint. Not too much, just enough to cover the joint in the area where we're going to solder.
I notice you're working in a darkened area. Any reason for that?
Well, I've turned off my bench light so I can see the color of the ring, so I can just watch the temperature for the solder to flow. And also, I have a little box that I keep my solder snips in. I pre-snip the solder just to save time. And we want to take just a small piece of solder with the tweezers and place it on the joint that's to be soldered. We don't want to use more solder than we need.
Do you place it on the outside of the band, or you try and reverse it and put it so it's resting on the inside?
I usually place it on the top, whatever's most convenient and easiest. But then we'll come in with the torch. Now we're watching to see the ring turn color to become a little red here. heating the ring up, waiting for that solder to flow. It's just about ready. And there it goes.
What's you're going to put it into a solution?
Well, now what we're going to do is we need to wait for it to cool down on its own, because we can't quench the ring with the stones in there until it's cool, or you could shatter the stones. When sizing a ring with stones in it, there are some stones that won't take heat, and there are some that are. The diamonds will take heat. Usually the rubies and sapphires will take heat.
But I guess all of them would suffer if they were have a wide range of temperature. In other words, very warm and suddenly you chill it, then all of them might be subject to shattering.
Sure.
So that's the basic reason why you're waiting to allow it to get to room temperature.
Yeah, they all will experience shock if they're going from hot to cold to abruptly.
This is a close-up of the area that has been soldered, and it's readily visible. It will not be visible once the finishing process occurs, and we'll be seeing that ultimately. But right now, this is the area. You can see it's an excellent soldering job, and it almost blends to the eye, but we'll improve upon it as we go through further steps.
Okay, what we're going to do now that the ring's cooled off is remove the fire coat that we put on the ring to protect it from fire scale. And what I keep my pickle solution in, which will remove the fire coat, is a crock pot which heats up the solution. And the pickle solution is Sparex number 2 and water. So I'll drop that in there, leave that in there for a couple seconds, and with my copper tongs, I'll grab hold of it, and that's removed the...
You mentioned copper tongs. Any special reason for using copper tongs?
Yeah, in this solution you don't want to put anything other than copper or bamboo in it, or it could ruin the solution.
And you're rinsing it in water, I see.
Yeah, then I'll place it in water and to neutralize the Sparex. What we're going to do now is round out the ring. So we'll place it on the mandrel, double check the size, and it's right down at a 7. And we'll just take our hammer and round the shank out.
What kind of hammer is that?
Okay, this is a double-headed hammer. One side has a fiber, kind of a plastic fiber end, and the other side has brass end. We're going to use the plastic fiber end so we don't damage the shank.
It prevents marks, I assume.
Right. Okay. A nice round shank ready for filing and sanding prior to polishing.
Why do you need filing? What's the purpose of filing?
Just to remove any excess buildup of solder around the joint, and then we'll sand it to smooth it out further. Well, what we're doing now is filing that solder joint. It's important to keep control of the file, moving in one direction, following the contour of the ring. But there's not much metal to be taken away, so just nice and slow. You just want to take away that little bit of solder buildup around that joint. And again, it's just nice controlled action with the file. One direction in the cutting edge, cutting direction. We'll go all inside, outside, and both sides.
I notice you're using a half-round file.
Yeah, I'm using the half-rounds file, and it's a number 4 file. Not a lot of bite to it, just enough.
It's not coarse then?
It's not too coarse, no. Like I said, there's not a a whole lot of metal we want to remove. Okay, once the filing is done, I usually take a little bit of fine sandpaper on a sanding stick and go over it prior to polishing.
Would emery do just as well?
Yeah.
And that's removing scratches from the file, probably.
Yeah, it's just making it a little smoother so we don't have to spend as much time on the polisher. Sometimes when a customer wants a ring size, they'll have a ring that maybe was on their pinky finger and they want to move it up to their ring finger, so the ring needs to be enlarged. And what we're going to do now is size up this ring. It was approximately a size 3.5 and it needs to go up to a size 5. So what we'll do is cut open a section of the ring and open it up, enlarge it, and add a piece of gold sizing stock, the same caratage as the ring. This is 14 karat ring, so we're going to add a section of 14 karat sizing stock. Now this ring's going from a 3.5 to a 5, so that's approximately 3.5, 4 millimeters is what we're going to put in there.
Gold sizing stock is available in various carats, I assume?
Yeah.
In various sizes?
Mm-hmm. Well, we can roll out whatever size we want on the rolling mill, or it can be bought, purchased, the approximate size that you need.
The sizing stock should be pre-sized to be sort of go into band properly before you get involved into it, I assume.
Yeah, you can do your filing and whatnot afterwards, but as close as you can, get the sizing stock to fit the area that you need to add it to. Okay, this is a small section of sizing stock right here that we're going to fit into this area of the ring. So what we want to do is check the fit here. It needs to be adjusted just a little bit down. So what we'll do is file it until it fits just right.
You're making sure the edges are flat so they
Yeah.
fit evenly.
Nice and flush. And again, we're going slow. Take a few easy strokes with the file.
Some people call that adding a block, but no matter what you call it, you're inserting metal to cover the space that was missing when you enlarged it.
Okay, that's a nice fit.
I noticed that the material is being held in locking pliers rather than tweezers. It's more secure, I assume.
Right, hold it steady. I'm using the parallel pliers. Have a nice firm grip on them. Okay, we got the sizing stock cut and fit for this area here that we're going to size. And what we do is put a little flux on it, on that piece of sizing stock. A little bit of flux on each side here where it's going to be soldered. And what we want to do is we've fire coated it, put our fire coat on the ring, and we're going to set a piece of sizing stock in here very carefully. Using the tweezers.
appears to be a very delicate operation and requires a lot of patience.
Well, what we want to do is get the best fit possible. Okay, now what we'll do is preheat the ring, burning the fire coat off.
And you're going to be soldering in two places at each end of the little piece of metal.
Right, we'll do one side at a time. That way we'll make sure it's fit in there just right, that the seams are nice and tight. Okay, once again using a pre-snipped piece of hard solder. Always using hard solder on the repairs, on the shank. Put a little flux on it and lay the solder right on the one solder seam with the torch. And again, we want to turn off the bench light so we can see the color of the metal a little bit better. And we're going to come in here and start heating up that area around the solder joint. Bringing it slowly up to temperature. And we can see the metal starting to change color, becoming a light red. And the solder's flowed into the joint. And what we're going to do now is let that cool down a little bit and then adjust it and solder the other side of the seam. What we're doing is the ring's cooled off and we're going to adjust that second side of the solder joint for that sizing stock using the pliers and your fingers and getting that nice and flush and centered, and that looks good. And we'll set it back in the third hand, adjust it, grab another piece of solder, hard solder.
You always use as small a piece of solder as possible.
Yeah, you just need enough to flow into the solder joint, and any excess solder will just have to be removed afterwards.
And the solder is always the same carat as the band.
Well, we always use a hard solder when we're doing sizing.
How about color of the solder? Is that vital? Or?
Yeah, there's, on a yellow gold ring, of course, you'll want to use yellow gold solder. On white gold solder. And we placed piece of solder right on that solder joint, and once again we're going to heat it up to temperature. And there we are. Solder's flowed. Now we'll wait for the ring to cool and shape it on the mandrel. Get it nice and round. Okay, what we're doing now is we place the ring once it's cooled down on the mandrel, and we're going to use the fiber plastic end of the hammer and just pound it round and shape it. Now it's ready for filing and finishing.
This is a close-up look of the work that was just completed, and it's quite rough at this time. The finishing hasn't been started, but just to show you how secure it is, and it is a perfect fit. Obviously there'll be additional work to finish it so that that will no longer be visible to the naked eye.
Okay, what we're doing now is filing that area that we just added the sizing stock to, fitting it nice and round, getting it fairly smooth, and ready for the final polishing steps. This is the Steam Master steam machine, and we use this for cleaning up the rings prior to doing work on them. What we'll do is ultrasonic clean putting the ring or whatever piece of jewelry we're working on, and then use the steam machine to blow any dirt out of it. It has about 60 to 80 pounds of pressure, and the steam under the pressure. Move dirt from the ring.
This is a close-up of the ring. It's been steam cleaned, and as you can see, there's an area right there where the prong is actually missing, and the prong replacement or tip replacement is going to be done next job. And the well, or the holding area where the stones go, has been thoroughly cleaned. I might add that in all cases, prior to working with it, especially if you're going to be doing any soldering, you make sure that your ring is clean. And if you have access to a steamer, it's a giant step toward doing it much more quickly and more thoroughly.
Getting ready to rebuild the prong here on this ring, we're going to file the area where the broken prong is, file it smooth and flat so we can lay a new piece of wire on there for a new prong.
You're going to add a complete prong?
Yeah, we're going to add a prong about a 1/4 inch long to the area where it broke off. And we're filing a nice flat area that we can adhere solder to.
Is that an unusual project or one that occurs quite a bit?
Now, broken prongs are something that happens all the time. The tipping, what it looks like. This is your prong, and over here you have your stone, your diamond or whatever, and your prong coming up, and you'll file this smooth right along here and lay your solder. This is your solder right in between here. You're going to lay a small piece of solder there, and then you're going to have your tip, which is going to be or your prong, whatever. You're going to have that and lay that on top, and then you're going to heat up this whole area here together until that solder flows and these join together. And then you'll file this all smooth, and it'll look as the original one-piece prong.
Is it possible just to use the solder instead of using the tip itself?
Okay, sometimes for expense reasons, instead of using this piece of metal, which will actually be the same thing as the prong is made of, if it's 14 karat gold, this would be a 14 karat gold tip. Sometimes to save money or time, what people will do is just use a large piece of hard solder on top of the prong. And it's not as good a method of tipping as using...
Is it as durable?
No, it will wear down faster, and so you'll be tipping it again in the future sooner than you would an actual piece of 14 karat tip. Okay, what we're doing now is we're going to fire coat the ring, get ready to solder this prong on here. So we fire coat the ring all up, and we're going to preheat it.
Once again, working in a dark area.
You have to watch the color of the metal, make sure it doesn't get too hot and melt down.
The size of the tip on your torch is important, I assume.
Right. You need enough heat to heat up the metal. And we'll place a little bit of flux. And then we're going to place a small piece of hard solder on there. Once again, we don't want to use too large a piece of solder, just enough to get the job done. Put a little bit of flux on it. Place it on the area where the prong's going to be. Then I pre-cut a small piece of yellow gold wire to use for the prong. And we also fire coat that and place a little bit of flex on the end. Preheat it. Now we're going to bring the ring up to heat before we bring the wire down into it. We're just trying to get the solder to flow onto the ring, and then we're going to place the wire down on top of it.
So the solder will flow before you actually touch it with the wire itself.
Yeah, hopefully simultaneously we'll do that. Just as it starts to flow, place the wire down in there. And that fuses together. Okay, well, we used a little bit longer wire than the rest of the prongs, and that's just so we could hold it in place and do the soldering easier. Now we're waiting for it to cool down, and we're going to put it in the pickle pot and clean it off and get it ready for finishing. We'll trim the prong down to the level of the others, and then it'll be ready for polishing.
This is a typical ring that has been in use for some time. There's a diamond in the center of this rose, and the prongs are holding it are well worn. In fact, it's just a matter of time until the stone will be lost. So to prevent that from happening, the owners brought the ring into the jewelry repair area, and these little prongs will be re-tipped. And that's a different technique in some respects than what you've just seen. So now we'll have Vinnie de Padova illustrate tipping to make a more secure retaining area of the stone.
Okay, what we're doing now is fire coating the ring prior to tipping that center diamond. I fire coated the ring and preheat it a little bit. Burn away the fire coat.
The flame is not affecting the stone, I assume.
No, not with the fire coat on it. The diamond will be able to take the heat. Now, we pre-cut our solder. We're using white gold hard solder. The tips are white on this ring. And using a very small piece of solder, we're going to set it on the tips that need to be done. And come in with the torch and heat up the base of the tip and flow the solder onto there. As I clipped a small piece of white gold, just a little piece of white gold wire will work, and I'll take with my torch and heat that little piece of wire until it balls up. It makes a little ball, and then I'm going to take that little ball of white gold and I'm going to flatten it out using my hammer. I'm going to take and set it on a metal block, and using the brass end of the fiber and brass hammer. I'm going to come in, flatten that out, and that's going to be our tip. That's what we'll be using for the tip on top of the solder that we just flowed. So I'll take and put a little bit of flux on it and set it down on top of the solder that we just flowed there. Once again with the torch, we're going to come in and we're going to heat up the base where the solder is. And when that solder starts to flow, it'll adhere to the tip. Alright, solder's flowed, and now we have a tip ready to be filed and finished.
The thickness of the tip is exactly that of the thickness of the material you flattened out.
Right.
And you're going to just repeat the process on the other tips.
On all three of the others, we'll have the same process. Okay, what we'll do is we'll file the base of the tip using a small file, and then use a cut burr to round it out in the final process. Cut burr in the flex shaft.
That will shape all the tips so that they're identical in appearance.
Right, they'll all be rounded smooth. Okay, what we're doing here is we've got a large ladies ring with a large center stone, and it's set in 6 prongs. Now the center stone is a little bit loose, and what we're going to demonstrate here is a method of tightening the center stone. This method is called the vector method, and what we do is we take our parallel pliers and we'll come in from opposite sides. We'll take 2 prongs and gently squeeze them together, and go to the opposite side and gently squeeze these 2 together.
The purpose of going to the opposite sides is to maintain the stone so it'll be straight.
It'll apply even pressure to the stone and bring all the prongs in evenly and tighten the stone.
In this case, the prongs have not been damaged. The stone just isn't.
The stone has just worked itself loose.
Mm-hmm.
And so, always working opposite sides, we just gently pull the prongs together until the stone is tight. And now the stone is. Okay, this is the ring and the prongs that we tightened, the 6 prongs. We've pulled them all together using the vector method and tightened the stone up in the mounting.
Is there another method that not called the vector method? There's more involved, I assume.
This would be the best way to adjust either a 4-prong or a 6-prong mounting. We've got a 14-karat rope or nugget bracelet here, and it's busted at one of the links. And what we're going to do is rebuild this hinge area in here and attach it together, make it back like it was new. So we'll be performing that repair right now. Okay, what we have here is a close-up view of that nugget bracelet, and this is the area of the link that is going to be rebuilt. What we're doing now is removing the old pin that on one side of the broken link. So I'm sawing that out of there. And I'm going to file that smooth.
So the chore is replacement of the pin.
Right. Right, the pin and also the tube on the other side of the bracelet that section will have to be removed also and replaced. And what we're going to do is we have a little section of tube here. We're going to cut off a piece to put solder back onto there. So I'm going to soften a little section of this tubing. There.
The third hand is holding the area to be worked upon.
What we've done is cut a small section of the tubing for the link and placed it on the area where we're going to be soldering it. What I'm going to do, we'll check the fit here, and it seems to be good. I can file it down later. Any adjustments that need to be made. We're going to fire coat this. And preheat it. Burn the fire coat away. Place the tubing right on the area to be soldered. I'm going to put a little flux on it here. Okay, we've got the tubing placed on the hinge here, on the nugget link, and we need to use a small piece of solder here. And we'll put a little bit of flux on the solder, and try to find a nice, delicate way to put that on there. Okay, what we'll do now is heat up the piece. Trying to heat the link and the tube and the solder all evenly so that it all flows together at once. This is the area here that's going to be soldered. We're heating it up slowly.
And notice you're keeping the torch moving all the time to heat the entire area.
Right. Okay, now we've got the solder to flow. The link's cooled off a little bit since we flowed the solder, and we've got the tube on there in the center. Now what we have to do is show we need to fit these. So it needs to be a nice tight fit. What I did was cut the tube a little bit too long so that we could adjust it now that it's soldered on there. And I'll take my file and run it up the side of that tube. Each side gets filed nice and smooth. And double check the fit again, the link. And that fits nice and tight. That's what we want, a nice tight link here. So the next step now will be to drill out the tabs on this side of the link.
This is a draw plate, which allows you to convert in this case wire, to different sizes. These holes using backlighting indicates the various sizes that wire can be drawn through and resized.
Okay.
And that's all there is to it.
Okay, this is the tube that we soldered on to the one side of the link of the bracelet. And here's the side that we drilled out, here and here. And this is the piece of wire that we've drawn that will connect the two. We'll go through both sides and connect the bracelet together. This wire was drawn so that it will fit very tightly in here. It will be a real snug fit.
By drawn, you mean compressed through that board with holes in it, that metal with holes in it?
Right, that metal with holes in it, which is called a draw plate. It reduces the size of the wire. We started with a fatter diameter wire, larger diameter, and we reduced it down to the exact size we needed for a real snug fit here. Okay, here's the two links pushed together with a piece of wire pushed through the link, and it's all connected together now. What we need to do now is trim this down and dap the edges, and we'll have the completed piece ready for polishing. Okay, we're going to file that pin down that's connecting the links together. Get that flush. Forward motion with this file. Nice and easy. Okay, and we've got the pin flush. And right now what we're going to do is dap the ends with a punch. Using a metal block here. And take the punch, set this down on top. Okay, what we're doing now is dapping this pin, ends of the pin. Do one side and then the other, and that'll keep the pin from working its way loose. Just like that. Okay, we've got a common repair problem. This is a sterling silver chain that one of the links is broken, and we're going to solder it back together. So we'll demonstrate that now. We've got the chain set up, the link that we're going to solder. What I do is I take an old razor blade and clip it up and make a little stand that you can put the chain on. And it holds it really nicely for soldering. And put it into the third hand, and now we're fire coating it. And there's the joint we're going to solder right there. So I'm going to preheat it a little bit, burn away the fire coat, and we've isolated that link right here. So that's the only thing we'll get solder on. So I'll place a little bit of flux on here, and then I'll take my little clipping of solder, real small piece. So this is a real small joint here that needs to be soldered. So I place it right there. I'm going to bring my torch in and slowly heat it up to temperature. And it doesn't take much heat.
You don't really need a hard solder for this, do you?
No, usually I'll use an easy solder for this. Silver. And there it goes. It flowed just nice. What we're going to do now is the final finishing process on some of the rings that we sized earlier. This is one of the sized rings, and we're going to do the final polishing right now.
And now Vinnie will give a quick look at how he finishes a ring. Please note that he has a special buff, an emery cone, which fits in the inside of a ring and gets rid of any marks that may be visible there. This will vary. The coarseness will vary. Sometimes I use fine. Depends on the thickness or the size, the depth of the scratches that are to be removed. And one interesting aspect of this entire thing is that he's holding it in his bare hands, the ring. You can always tell the difference between a professional and an amateur, and by that I mean how long they've been using rings and handheld. Right now he's going to remove the cone and put a triply buff on. Please note this buff is quite wide and will generate a large amount of heat. He's able to hold in his hand because of his experience, but I would advise, if you're just new to the field, to get some leather gloves, cut the fingers off, or you can actually purchase some little leather protectors that fit over the fingers from most jewelry supply stores. Also note that he has the ring in the bottom part of the buff. If you held in the top part, chances are it would be torn from your hand and just hurled across space, and so it's advisable to hold it in the bottom part. He's also using a very light touch, and while that uses triply to remove scratches that may be in there, the light touch is imperative for many reasons, because it does generate quite a bit of heat. It does a very effective job. He's working on the outside of the ring right now. Prior to this, of course, was on the inside. This is a triply buff. Ultimately, he'll move to a white diamond buff, and then finally to a red rouge, which would be identical in use to the white diamond buff, except that you have a whole much more pressure. In between, he's eliminated contamination by washing the ring thoroughly, and making sure that there's no triply being carried over, so it contaminates his white diamond, which is on this buff right here. And he's once again using the light touch, and he keeps it moving so that you don't get any one area that receives extra pressure and extra wear. And he's removing any scratches that may have been visible on the outside of it. And that's simply all there is to it. Follow through with a steamer and the other processes that is normally used when completing materials such as this. Sometimes customers find that they have a missing earring, or perhaps they have a ring that they would like to have duplicated. Making the mold is a very important procedure. It's not overly technical, but it's a step-by-step recipe you have to follow. In this case, we're using material from the Contenti company at Contenti, 530 Wellington Avenue in Cranston, Rhode Island, 02910. I'd like to point out that this is not a commercial for that company. We're not associated with them in any shape, manner, or form, but perhaps you may want to contact this organization or any other that produces material you can use. Phone numbers indicated are 800 number 343-3364. The material they use is known as Moldex, M-O-L-D-E-X, which differs greatly from natural rubber. Before starting, you have to realize that Moldex mold rubber is easily contaminated by chemical residues from natural rubber. And these residues are present in all models, mold frames, and mold plates that have been used in the past on natural rubber. So it's ideal to use a new mold. We're just going to leave this picture on the screen while I mention this because it's important to start at this point. If you want to use your old mold frames and plates, it's necessary to scrub them clean with a brush and a cleaning solvent, such as naphtha or rubber solvent, or any lacquer thinner, or even lighter fluid. And if you have a sandblaster, you should blast the old plates clean. But now let's get started and give you some idea of what's necessary. Things you're going to need will include a small brush, and there's a small brush that will be used. And a small quantity of mica powder. And This is all available from this company. A pair of mold plates. That's a mold frame that's resting on mold plates. And these plates come in different sizes depending on what you're working with. And they use 6 brass locators with prongs folded in. And these are very handy little items. And they eliminate the fact that you have to cut, as so many people do with natural rubber. And we'll demonstrate how that is achieved. A cutting knife is necessary, though, for some small areas. Oh no, I believe it's just used to use a Moldex rubber. And a screw rod and button is required. Compact, small. You'll see that in use. And a flexible steel ruler. It's advisable to have something like that available. Well, now step 1, we'll start with make sure your model is clean and free of chemical residues. And let's take a look at the model. And this is the model that will be used on this project. This happens to be a silver ring. It could be anything, any piece of jewelry. But in this case, we're going to be using the silver ring. Make sure it's free of chemical residues from natural rubber, and a high polish on the object is desirable. Step number 2, and this really starts the process, is to cut sections of Moldex to the length and width of your mold frame. And we already have that. Give you some idea of what we're going to be using. The Moldex is a large sheet of rubber in the foreground. We'll be cutting that to fit in that frame. The frame is now in position to give you some idea. We've cut a small piece of Moldex rubber and placed it in the frame. Actually, it depends on the object that's going to be used. 3 pieces of Moldex rubber would be used in this case. It's cut to size, and it's because it's a synthetic, it's very easy to work with.
It's not centered.
Moldex is a 1/4 inch thick, and you can use 1/2 inch, 3/4 inch, 1 inch, or 1.5 inch thick mold frames. You peel off the paper backing of the Moldex and insert it in a frame such as this. And for a 1 inch thick mold, you place 2 sections of Moldex into the mold frame. And for more or fewer, it depends upon the mold itself. Press the rubber to the bottom of the mold frame, position your model in the center of the rubber, and then press your model into the rubber until the top edge of the ring shank is nearly flush with the rubber surface. You can see that at this time we have the 6 brass locators in position, and the fold each of the 4 prongs on each locator is toward the center of it. Now these little prongs hold the locators in position. After bending the prongs, you press each locator onto a flat surface so that the prongs are all flush with the table surface. If it sounds involved, it really isn't. It's just a matter of following this procedure. You put 1 locator in each corner of the mold. In this case, we've just used 4 locators rather than 6. But locators should be at least 1/8 of an inch away from the side walls of the mold frame, because the side walls get very, very hot. The next step is, once you have this in position, this material in position, is you lightly brush some mica powder over the entire surface of the rubber, and you blow off any excess powder from the surface. And we'll do that now. He's applying the mica powder right now over the entire mold area. And that mica powder is very, very important. It's going to eliminate the need to use a sharp X-Acto knife as you do with natural rubber. And sometimes you'll slip, and you'll find anybody who works with natural rubber to make molds usually has cut fingers or scars from past efforts. And so you make sure that the mica powder covers it completely, and any excess powder is blown away to minimize the problems. You place your sprue button and rod in position. We already have in position. And there's the sprue button that we were discussing. This comes with the entire kit that you purchase. Take a small piece of paper and fold it at a 90-degree angle. Now we're going to illustrate the next step. The small piece of paper has been put in position And what they did is put one flap against the wall of the mold frame, the other flap resting on the mold itself. That step makes it easier to watch the mold separation after it's vulcanized. And you take the remaining unpowdered rubber and place it one section at a time over the bottom section of the mold. And that step is now be visualized. At this time, the second piece of rubber will be placed over the entire project as it sets right now into the frame itself. And if after pressing the top section down, any areas of the mold surface are below the top edge, you may fill in those areas using scrap rubber. If after pressing the top section down, and it's necessary to shave off excess rubber if it goes above it, a flexible steel rule is useful for this project. You grasp the rule with both hands and place it at the center of the top surface and draw it towards you. And you turn the frame about 180 degrees, and then you shave off the other half using that ruler. And we'll demonstrate that also. Right now we're merely going to place the Moldex rubber into position and do that off camera. We do have an overlap of the Moldex, and so we're using the steel ruler to remove the surplus. In other words, it's a little higher than the mold frame. Just a wee bit higher, and so you sort of scrape it off, and that makes it flush with the surface. Reverse the position, you just go halfway in each case, and the Moldex rubber is easy to remove. Now you know when you complete it, you know it's exactly flush with the top of the frame. And there's a look at the Moldex rubber in position, ready for the next step. There are sheets of paper that come with the Moldex, and this is used as a protective device, you might say even an insulator in a sense. Now you cut it to size, some of it, and insert it right over the Moldex. And that will prevent the Moldex from sticking to the frames itself once heat is being applied. And you do that in both sides of the frame. The aluminum mold frames have been placed over the top and bottom, mold plates rather, have been placed over the top and bottom of the mold frame. And then you install the mold frame and the plates into a vulcanizer which has been preheated to 325 degrees. This is a typical vulcanizer. They're available in various sizes. This happens to be the Vulcatrol, and that is not a commercial for it. It's a unit we use in a workshop. And vulcanizing time is calculated on the thickness of the mold. For example, 15 minutes for each quarter inch of mold thickness. If you have 3 pieces of rubber in there, then it would be 45 minutes of time. 4 pieces, of course, would take a full hour. The temperature is 325 degrees. I might add, if you do not have a vulcanizer, we do know of at least one professional who would use the kitchen range, and he uses the same temperature. And it will work provided you have some way of keeping the mold, the rubber into position in the frame. And they do that by using a clamp over the top and bottom of the frame and clamp it in position, clamp 2 aluminum plates in position, and they'll hold it so that it doesn't overflow. So you can use a range of some type for this purpose, but if you're a professional or intend to do much of mold work, you certainly should have a vulcanizer. And in this instance, we take the frames and insert them into the area of the vulcanizer. And once it's inserted, you clamp down by using the pressure as a roller at the top of this, and by simply rotating that, you increase the pressure until it's held firmly and securely in position. And then, of course, the heat is on. We've had it preheated, and it goes on. In this instance, 3 pieces of rubber in there, so it would be in there for 45 minutes. Once the time has elapsed, you remove the aluminum mold plates from the vulcanizer. And to minimize shrinkage, you allow the mold to cool naturally, which means at least an hour, approximately an hour. If by chance you desire to douse it in water, you're going to find a shrinkage of up to ½ inch will occur. So obviously, unless you're working with a very large original mold, you would never do that. Allow it to cool naturally. And you remove the cool mold from the mold frame by inserting a steel rule between the mold and the frame, and you press the mold out. And so we'll give you an example of how that's achieved right now. We'll open up the frame, the mold itself. Once time has elapsed and the mold has been removed from the mold frame, then you simply separate them, and you do it physically. Open it up, force it apart, and you find that you're all ready to go. You have it complete, and it's in position. And you remove your original subject from that. You have your rubber mold. It's in 2 pieces, and it's very easy to close properly. The locators allow you to put them in exact position so that you can then use wax, create wax patterns from the mold. Flash, the Contenti Company, producers of the mold making set, has moved. The new address and phone number, 123 Stewart Street, Providence, Rhode Island, 02903. Phone number is area code 401-421-4040. Concludes our video. This has been an A. Goodman Lapidary Educational Video Production.